Super. Thanks, Kuldeep. So once again, I'm Arvind. I'm a senior manager for product at Amazon for OpenSearch. I'm really excited to have all of you here for OpenSearch Con for the first time in India. Since we launched OpenSearch in 2021, the support from our users, developers, partners, and the open source community at large has been instrumental in making OpenSearch the feature-rich platform it is today. At the heart of it, OpenSearch is based on search primitives. It is an information retrieval system built on Lucene, and it's primarily used to find relevant information quickly. In the initial days, search was about keyword search. You could search for products in a catalog. You could search for documents in a repository. And eventually, with how powerful search engines are, they were being used for analyzing logs, understanding anomalies, identifying threat patterns, and understanding user behavior insights. So the application of a good search engine was everywhere, right? And as you'll see today, based on the variety of use cases that OpenSearch is being used for. Along with the evolution of the use cases for which search engines were being used for, with GenAI, how people were interacting with search engines also evolved. With the advancements in large language models and natural language processing, search engines are powering chatbots, where it simplifies how you could get support, how you troubleshoot in an automated and interactive manner. Semantic understanding of data has become table stakes. You no longer search for dog grooming and expect a list of dogs and a list of bridegrooms, right? It is becoming imperative that search engines can understand the intent and context of what you're searching for. And OpenSearch is at the forefront of all this. For example, Amazon Music uses OpenSearch's vector similarity search to power music recommendations across 100 million songs. OpenSearch processes 1 billion vectors, handles 7,100 queries, vector queries per second at peak load to power all these song recommendations across geographies. OpenSearch's vector architecture makes building machine learning-based applications really simple. Most organizations do not want to build their own models. They want to pick from popular ecosystem models, choose what works best for the use case, and build applications quickly. With neural search, OpenSearch enables you to encode text to vectors, and enables vector search during search time and ingestion time. And it powers a lot of features like hybrid search, semantic search, conversational search, all of these which are changing how applications are being built today. Hybrid search is really interesting in how it lets you blend semantic results with the power of a keyword-based search. So you get the best of both worlds. You can bring your own corpus to fine-tune models, as well as use mechanisms like sparse retrieval that gets you the power of an AI-based semantic understanding with the efficiency of a lexical search, a keyword-based search. You can also search within images without a lot of pre-processing or labeling using OpenSearch's multimodal search. Conversational search is a great example of how OpenSearch leverages large language models. You can interact with OpenSearch in natural language, ask questions, refine your answers further. It's like having a dialogue between a user and a large language model. With a lot of these advancements that we've done to OpenSearch, several organizations use OpenSearch to power unique experiences. And it's my pleasure to invite Nikhil from Adobe, who will tell us how they're leveraging OpenSearch within their application.
Good morning, everyone. I'm Nikhil, Director of Engineering from Acrobat Services, Adobe, and I'm going to be walking you through how we are leveraging OpenSearch in Acrobat for building our GenAI capabilities. Okay, so I think PDF, I, I'm pretty sure everybody in this room must have used PDF at some point or the other, or must be using every day for their day-to-day work. Now, PDF is a very dominant file format, has been in the existence for last 3 decades, more than 30 years, but I think it has been very static in nature. Like whether it's a one-page PDF or it's a 100-page PDF, you open it up in the application, go line by line, page by page. But we are changing all of that. Now, you can interact with PDF, you can ask question with PDF, you can summarize PDF, and you can decide whether you have 5 minutes, you have 1 minute, or you have like 30 minutes in terms of going through the PDF, and all of that is now possible. So we have created a capability based on using generative AI in which you can really ask questions and get answers along with attribution. Now, what attributions are? Can we have the video on the screen, the link that I have on the slide?
Adobe Acrobat, but it's over 20 pages long. It can take a lot of time to find the right information, summarize it, and write an email. With the help of the new AI assistant in Acrobat, I can get that done in a fraction of the time. AI assistant gives me an overview, suggested questions, and a prompt to ask my own questions about this document. I'm going to ask AI assistant a question about the time off policy. It responds with the policy based on the document. I can even click on references to learn more and check accuracy.
So just stop there, stop right there. So you get the answers, and then there are references, and you can reference back to the content in the PDF. So the reason this reference is extremely important is we know that at the end, I think LLMs are really useful. They really provide us a lot of informative thing. We can really analyze the content. But LLMs do hallucinate at times, and you can do your best, but hallucination is not a problem that has been solved with the LLMs. Now, this attribution is something that really lets you know that this is really a real content versus something that LLM might have made up from its side. So if there is a reference, then obviously you can really check back the answer and then the source of the content from which the answer is coming. So we can go back to the slide. So that's about the question and answer along with the attribution. How we are really making it happen. PDFs are a binary format. It's not something that we can simply take and feed into LLM. There is a lot that happens behind the scenes. So whenever a PDF comes, we first of all convert PDF into a format that a LLM can understand. We have our own extract API that Acrobat we provide to the external world as well. And that is something we are using internally to convert a PDF to a JSON format that LLM and all the machines can understand. And then for a very long PDF, like 100, 200 pages PDF, we chunk the JSON into smaller sections. We create embeddings for those sections, store that inside OpenSearch, and now we create a session that we return to the user. Now, when the user asks a question, at that time, we take a query string, convert again that into an embedding, and then we get the content from the session about all the information inside the PDF that we have basically extracted in the previous ingestion step. And then we use the overall processing and different LLM models in terms of creating an answer. Now, once the answer is available, at that time, we take the answer, we take the question, we have our own algorithm. But at that time, we use an embedding service to create an embeddings of the answer and the question. And then we again go back to the OpenSearch vector DB and do the vector similarity search, get the sections which are similar, and then analyze which sections have contributed to this answer and surface the attribution as was shown in the previous video. So that's about the workflow, entire workflow, how we are making use of it. So it appears simple, but it really took a lot of effort in terms of getting to this point and a lot of iterations and a lot of experiments. Okay. So when we started off, one thing is that PDF, our Acrobat family of product, is really a product base with a very large customer base. In fact, this is one of the products on which we have the largest customer base in Adobe. It is used by masses. So whatever we were building, it really had to scale. Scale for the numbers that I'm showing, like 100 million plus PDFs per day. That is something we should be able to process at least in the beginning. And eventually, we would, I think it is going to be like 500 million plus PDF if we scale out to each and every user who is using PDF out there. But at least in the beginning, we targeted 100 million PDFs per day. And then the use case we have is that user opens a PDF, then basically it kind of goes onto the cloud in real time. We have to do everything in almost near real time, cracking open the PDF, indexing it inside the OpenSearch, and then querying it back. All this should have like very, very low latency, less than a second, all the content getting inside OpenSearch and then becoming accessible. And then in terms of RPM, that is what really hits the servers most. I think it should be like more than 1,000 documents that we should be able to process in less than a second. And at the end, it has to be cost effective. Cost is not important when we are building next generation features, but it is important at the end. So it is in the 1 to N list at the end, but it has to be cost effective as well. And then, when we analyzed different solutions out there, OpenSearch really fits the bill for all the requirements we have. That is something we started off with, doing all the experiments. And then the way we are using OpenSearch today is OpenSearch. We are using KNN with a cosine similarity to find the related sections in the document. The reason to start with OpenSearch was also in the beginning, we were not sure what exactly algorithm, vector similarity, and the different approach we will take, like HNSW, KNN, or whatever. So we experimented with the different approach. We finalized on KNN with the cosine similarity. But I think the beauty of OpenSearch was that it was supporting multiple different vectors similarity metric, like Euclidean distance, and then Jaccard similarity and all. And then between KNN and other algorithms, so we could easily experiment with all of them. And then with different embedding models, we could really use a small embedding model, big embedding model, and OpenSearch was very flexible in terms of using all of them. And then OpenSearch scales nicely for all the different load scenarios that we sort of projected, the different projections that we did. So all of this, I think it was slam dunk for us to go with OpenSearch in the beginning, and that is what we built our solution on. So one important thing is that the use case that I showed where user is opening the PDF and then we are asking questions and all of it. One more requirement for us was that it has to be a transient. A lot of our enterprise users do not want the document content to be stored for a long time, so it has to be transactional in nature. That was another use case that we had. So document should be context, we cannot store the document on the cloud. So as I mentioned, I think we have to do a lot of it on the fly in the near real time, and then indexing has to happen in the real time as well. And so OpenSearch really powered that use case of indexing in real time and then querying in real time. That is different than how usually OpenSearch is used, because in OpenSearch usually it's a bulk indexing and then the content remains there for a long time, but that's not our particular use case. We are storing content and then we are removing content that I'm going to be covering in the later slide. So we had to remove content. As I mentioned, I think a lot of our enterprises customer wanted the system to be transactional. So one way was that we create a cron jobs and then remove all the content and a lot of tons and tons of code that we have to write. But again, OpenSearch bailed us out here. So the way OpenSearch has a very nice feature that it has a rolling index where you can create an index, you can define a lifespan and a refresh rate. So we started off with that. Every document is going to be indexed on a separate index, and every hour we will create a one index which will have a lifespan of 12 hours, and in 12 hours the index will automatically get deleted. So it really helps us to keep the data refreshed. If we have to change indexing and embedding models, we can easily sort of plan out our gradual rollout with this strategy as well. And at the end, the biggest advantage we are getting is that the content is automatically getting deleted in 12 hours, something that we required for this solution. And then the transient nature, unlike other vector DBs, we are regularly, there is a lot of churn in the content that we are indexing content in real time. We are kind of querying content in the real time. We are removing content in the real time. With all that churn, it's a transient usage, a non-typical usage, and then the policy, the 12-hour, in fact, we applied a 12-hour policy, but this kind of a time-bound lifespan of index really saved us a lot of effort in terms of building this solution automatically, where we can really have the data indexed and then queried and then removed automatically after 12 hours. So numbers at a glance in terms of what it really takes to build this kind of a solution. We have like at peak right now, we have 11 million embeddings, and it is rapidly growing. This solution we have launched just like a month back, and it is available. All of you can go and try it out. It is available as a trial in Acrobat for free as well, so you can just have a taste of it. I will highly recommend all of you to go and try it out. And it is increasing. We are already at 11 million embeddings. Then the 12-hour window that I said, and then a buffer, n+1, we have 13 indices at any point in time. And then there is an algorithm where we have like, we are separating two separate chunk sizes, 100 and 200. So it automatically becomes 26 indices that we have to create at any point in time. And then for every index, we have 18 shards. So overall, it becomes 468 primary shards, and then there are equally, we have replicas for all those 468 primary shards, so it becomes 936 secondary shards. Each embedding is 16 KB, so at peak, we are using 120 GB of basically data in memory, and all of it is working perfectly fine. If even with all of this, we have a latency numbers which are less than 5, we targeted for 1 second, we are under 500 milliseconds, so indexing latency is just 395 milliseconds. 0.395 milliseconds, and then the search latency is like, I think the dot is misleading, it is 242 milliseconds. And then the peak throughput at which we are doing this is 3,650 embeddings per second. We are either putting inside the database or querying from the database. So that's about it. Thank you. With that, I'll hand it back to Arvind. Thank you, everyone.
Thank you, Nikhil, for that really interesting use case. So we spoke a lot about search and machine learning. A lot of people are turning to OpenSearch to solve observability problems. With OpenSearch's strong log analysis capabilities and the ability to tie in traces and metrics alongside their logs, makes OpenSearch a really powerful platform to gain insights into applications and solutions. OpenSearch supports open telemetry schema, Jaeger traces, query federation into Prometheus, and it makes it really powerful to analyze logs. It comes with a variety of tools that can help you derive patterns, derive anomalies, identify outliers, and the OpenSearch Assistant Toolkit, the extended toolkit that we launched last year and now is available in the search, is a great example of how we tie machine learning, search, and observability together. I'll play a short video to introduce the Assistant Toolkit.
As a developer, you work to deliver simple solutions to complex problems. As your applications and infrastructure continue to grow, so does the amount of data they generate. Getting insights from this ever-growing data can be time-consuming and requires specialized skills. Imagine if all it took was a simple question to quickly understand what's happening inside your systems. Generative AI is opening up new ways to interact with and discover insights from your data. We're excited to introduce the OpenSearch Assistant Toolkit to help developers build generative AI experiences to solve search and analytics problems. With the OpenSearch Assistant, you can build solutions that let you write queries using natural language, such as, "Are there any errors in my logs?" Or if you want to quickly see your data in action, try asking the OpenSearch Assistant to create a visualization. The OpenSearch Assistant unlocks a new world of possibilities for building powerful generative AI experiences and discovering rich insights from your data. Start building with the OpenSearch Assistant today.
Another popular use case for OpenSearch these days is security analytics. With a few clicks, you can enable 2,000 plus security rules across 25 plus AWS logs, such as AWS logs, VPC flow logs, Windows logs, Zeek logs, and many more. Once you set up your security rules, you can alert your users, stakeholders, using mechanisms like ServiceNow, PagerDuty, Slack, or use OpenSearch's built-in alerting mechanism. We also built a correlation engine that makes it easy to identify relationships between security findings across your logs so that it reduces how you can analyze and reduces the incident response time. OpenSearch as we've seen, is a feature-rich platform, and it provides a set of features across security, search, and observability. It also makes it extremely easy to build products on top of OpenSearch. I'm really excited to invite Netra from QuickHeal, who'll speak about the product that they've built on top of OpenSearch.
Very good morning, everyone. I'm Netra, VP Engineering at QuickHeal. Just a quick introduction about QuickHeal. QuickHeal is an indigenous cybersecurity, the only Indian company, proudly serving thousands of enterprise customers across different verticals, including government, and we are currently the leader in retail space in India. Today, I'm going to give you a sneak peek in terms of how we are using OpenSearch for our leading threat detection and response platform named as Seqrite XDR. So when we talk about cyber attacks, unfortunately, the game is changing every day. These are some of the statistics which you can see that since 2021, we have seen a steep increase of around 72% increase in data breaches. Just in 2023, there were more than 2,500 successful data breach attacks. And obviously, the cost of dealing with any successful data breach attacks is very steep. Unfortunately, volume or the number is not the only challenge. Since this whole episode of attacks have started, initially the malware used to be very naive malwares, I can say, which used to inject the code into good known binaries, and the maximum response to that was creating the noise like crashing the machine. But over the period, the malware writers have become very sophisticated. Unfortunately, economics have entered into the attacks. And now we are seeing very sophisticated attacks across industries. One of the key observations what we have is 80% of the recent cyber attacks are the zero-day attacks. As the name suggests, the attack is brand new. That means no one has seen that attack any time before, and obviously the stakes are very high. Similarly, malware writers are now taking advantage of AI tools to write a very nimble malware, but with a very intentful catastrophe. You must have heard targeted attacks at the time of pandemic, especially on the pharma vertical. In order to typically keep a watch in terms of what is happening in a particular customer's organization, either customers set up high-end security operations team, or they engage with certain security operation team, but what it involves is literally having 20 plus odd different products, assimilating data across the organization, and constantly analyzing it. Now, the workforce which is required to do that, first and foremost, it's very niche, having the threat expertise, and it's very costly. So currently, we are dealing with both, how to detect the threats in time and basically restrict them in the play, as well as the cost of doing that. Seqrite XDR is a classic solution which deals for both these issues. So this is our leading cybersecurity incident detection and response platform. First and foremost, what it gives is a very wide visibility of a customer organization, may it be your endpoint, server, cloud workloads, network, application users. Because if there is any dark corner or a neglected asset, that might be the gateway for the attack. Now, tons of information gets gathered across our own sensors, as well as the other softwares, like email gateways, or for that matter, firewall. All this data basically married together, and the analytics basically happens on that to generate the alerts. These alerts are then correlated to form the logical sequence, and if any of the sequence resembles to the MITRE tactics or technique, then the incidents are created. But as you can imagine, the sheer volume of the data, what we collect from our own sensors, which is a very, I will say, curated data, and the logs what we get from other ecosystem, tons of alerts get generated and tons of incidents get generated. Because ultimately here we are dealing with a zero-day detection. So it's bound to happen that a lot of false positive will get generated. So for the problem like this, while it is important to concentrate on finding the potential true positive, it is also equally important to make sure that the false positive are slashed up. And Seqrite XDR basically does that by applying the correlation and the analytics as a dual process. As I said, that typically the SOC teams need to manage different point products because different point products can concentrate on the specific category in the workflow for handling such type of attacks. But XDR provides the inbuilt SOAR. That means, as an analyst, I'll be able to automate the incident triaging as well as the response through the playbooks which are getting shipped along with the product, as well as I can write a very sophisticated playbooks to dictate how to basically triage quickly, because dealing the volume at the right time is a crucial thing. So it's important to reduce your time to detection as well as time to respond. As we are dealing with, again, 0 day, you are as good and as bad as the knowledge you have for the previous attack. Very proud to say that QuickHill has a very state-of-the-art malware research lab, and we are also consuming intelligence from the threat intelligence sources across the global as well as local sources. The important aspect while dealing with the cyber attacks is also to see that whatever you got to know today, because every day you might cover some different IOCs, whether the same IOCs are lying around in your network, because at that time they were not known. So threat hunting is typically a very important step to keep sweeping through the network, sweeping through the past data to see whether what do you know today is lying around somewhere else. And again, this is a very complex process simply because what you are dealing with a huge data. Last but not the least, while you detected the potential threat, you are about to respond it. But response is not binary, that if this is the threat, this is what you do. It largely depends on the contextual aspect as well. So imagine that there is an endpoint having some unpatched software, or there is a server running a very business-critical application. If, as an analyst, I know this context, I might be able to calibrate my response much better. And that goes a long way in terms of effectively dealing with the threats. In general, as I said, that with our rule-based and AI-based detection, the first responder manual intervention goes away. With the playbook automation and the orchestration through our SOAR platform, the way you manage the volume of the alerts and incident, the manual intervention also is increasing. And with the great visibility, both in terms of assets, in terms of incidents, in terms of the time series, and actually how the attack has progressed through different time, really basically helps the SOC teams to maintain their SLAs as well as communicate right way to their customers. At the heart of everything, we have OpenSearch. How OpenSearch is really helping us here is, as I said, that we collect tons of information on a daily basis. Just out of endpoints, which I already mentioned that we actually take very curated information. Currently, the volume is around 3 TB data per day per endpoint. And this excludes other ecosystem logs that we collect. So it's a huge data, and that to heterogeneous nature. Anomaly detection itself is a very expensive operation because what you do is constantly search between the current snapshot versus the known good last snapshot. And this is, again, the complex operation because of the heterogeneous nature of the data. The correlation, which is really adding the intelligence that, okay, where you should be concentrating in the sea of alerts and incident, is nothing but a complex analytics as against the MITRE coverage. Threat hunting, as I already mentioned, results into near real-time search through the hundreds and billions of events. And orchestration also generates tons of parallel queries and the complex aggregation of the data. Now, to solve the problem like cyber attack, data is really the power, right? I mean, if you consider the stealth attack, where with some weak asset, the attacker has entered in your network, it's lying low, and basically just trying to cover another weak link to exploit. And after certain days, basically it proceeds to exploit that link. Now, if you don't have the data spanning all this time, pretty much it's difficult to understand, how the end-to-end flow is looking like, and thus potentially knowing that there can be attack in this thing. So having the data getting retained for as long as you can actually is an important thing, and that really affects the efficacy of the product. It's a costly affair for sure, but OpenSearch is helping us to lower the retention value by the ultra-warm nodes. So all in all, I want to thank Team OpenSearch for helping us to solve really complex problem for the cybersecurity. Thank you.
Thank you, Netra, for that, sharing with us how you built OpenSearch and Seqrite. We have a lot of interesting presentations lined up for today. I'm looking forward to learning from them. Hope you do too. There's an OpenSearch booth up front. If you want to talk to any of your engineers or product managers, they'd be more than happy to do so. Once again, welcome to OpenSearch Con.